Hi everyone, welcome back. So we are right here was where I ended. Okay, so if you remember in video one, we were converting from radians to degrees, and in each of those we said the pi cancels out. Well, what happens if I have a radian where there is no pi, right? So in this particular case, we have to kind of just do something a little bit different. So let's see. Right? And for this particular part, I'm telling you, please, to round to the nearest whole number. So let's look at these. Right? Okay, so let's say I wanted to change 3 radians to degrees. Well, now 3 radians is not the same as 3 pi radians. That's a very common misconception. It's not. So think of the 3 as somehow there was a pi in there, but then it got multiplied into the value. So this 3 already reflects the 3.14 being in there. Okay? So let's look at this first one. Let's look at what happens. Okay. Well, I'm using the same conversion factor. It's still going to be 108 degrees over pi. Right? I want this in degrees, so 180 degrees have to be on top. Well, now because this is 3 and not 3 pi, there's no pi to cancel, but that's okay. So I just do 3 times 180 degrees divided by pi. The only thing is, please, use the entire pi that's on your calculator. Don't use 3.14, because sometimes, well, lots of times, when you round it so quickly, instead of using the entire value, your answer may be off. So you may get 171 degrees, or 169 degrees, or 174 degrees, but if I had used the entire pi, it would have been this. And on the test and on the finals, that's what's going to be the correct answer. So try it on your calculator now and see if you get the same thing. Let's go to 4.5 radians. So again, there's nothing to cancel, but that's okay. I put in 4.5 multiplied by 180 degrees over pi. That comes out to be 4.5 times 180 degrees. Divide that by the entire value of pi. I get 258 degrees. So see if that's what you get. And then we're going to go to negative 2.7 degrees. Now you're looking at the negative, right? But that's okay. We do it the same way. So I do negative 2.7 times 180 degrees divided by pi. Same thing as I did before. And I get negative 155 degrees. Now again, notice with all of these, I am rounding it. Right now I'm telling you nearest degree. Another time I may say nearest tenth of a degree. Sometimes on the final it may be the nearest hundredth of a degree. So just be careful in how you round it. So now let's quickly, negative 155 degrees. And you're like, well, what's that? So let's quickly just review this if you have forgotten. When the angle is negative, right? So for all angles, we're starting here at the positive x-axis. And normally when it's a positive angle, from here I go this way. Remember with your quadrants, here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. And when I go along the quadrants, this is said to be moving in a positive rotation. If I'm here, and this is called standard position, when an angle starts with this initial side here, I'm in standard position. When I go counterclockwise this way, right, this is said to be a negative rotation. So negative 155 degrees. And by the way, did you notice that moving 155 degrees clockwise would be the same as if I were to move counterclockwise 205 degrees, right? Here and here. Because together, by me moving this way and then kind of moving this way, even though they're in opposite directions, I really form an entire circle. So that 155 degrees going backwards negative is the same as a positive 205. We'll get into that later, but this is the first instance of what's called coterminal angles. All right, so let's go and see what's going to happen with the next slide. All right, so now here's what I want to do. Now that I am an expert at converting from radians to degrees, I want you now to be able to convert from degrees to radians. So now we're going to go in reverse with this, because I want the answer to be in radians. The pi has to be on top. And when I convert from degrees to radians, there are one of two possible scenarios that you're going to be asked to do. So the first one is reduce to simplest pi radian form. Now sometimes the pi doesn't even have to be there. Sometimes it can just say reduce to simplest radian form. When you see that, this is what it means. So when you see that one yet? Maybe not. So we'll do both one. We'll do these. Okay, so here I've got 80 degrees. I'm multiplying by pi times 180. So actually, you know what? Let me do that. Makes more sense to do it this way. So I've got the first, now hopefully you notice that the degree symbols cancel. So this guy cancels with this guy. So I've got 80 over 180 pi, right? This forms a fraction. And then all you're going to do, because it's simplest, is you're going to reduce. So some of your calculators will be able to reduce for you. If not, you have to kind of do it by hand. I would cancel the zeros out. Then here I notice that they both divide by 2. So I get 4 9ths pi. Another way to write this is 4 pi over 9. So write the angle as a fraction and reduce. Don't forget to include pi with the answer. And I can write this as just 4 over 9 pi or 4 over 9 pi radians. Again, remember, radians is a unit that it's optional for you to write. Just like positive 3 is optional to write that plus sign. It's understood with or without that this is in radian form. So now when I go to the other problem, notice that I do 135 over 180. Reduce that, I get 3 over 4 pi. Here, negative 800 just again means I'm going clockwise, right? Multiple rotations. I'm going to get negative 800 over 180. Reduce that, and I get negative 40 over 9 pi. So that is what happens when I'm reducing this to simplest radian form. Let's look at the second way that you may be asked to also do this. So let's go to the next one. Okay, so here's what you're going to do for the next one. Here you're going to be asked to round to a specified place value. So let's go and do this. Okay, so exact same thing as before, right? I start off by pi over 180 degrees. The beginning's the same. Now I have this 80 over 180 pi. Well, in this particular case, there's no need to reduce because I'm going to have to use my calculator anyway. So use the entire pi in your calculator and be careful to round to the correct place value. So you could either do 80 times the pi, that whole 3.14159, blah, blah, right? And then divide that by 180. Or you could do 80 divided by 180 first, get a decimal, and then multiply that value by pi. Whatever you get, when you round it, in this case to the nearest tenth, I get 1.4. Go and do that and see that you also end up pleased with 1.4. And then let's look at the next one. This time I want it to be rounded to the nearest hundredth. So same thing, 135 over 180. Degree signs cancel. I get a pi. When I do this on my calculator, I end up with 2.36. right? So 135 times the entire pi divided by 180, or 135 divided by 180, then multiply by pi. Up to you. And then the last one, negative 800 degrees. This time I want it rounded to 3 place values. So I do this, negative 800 times pi divided by 180. I get negative 13.963, 3 place values, right? So that meant I looked at the fourth number here to decide whether to either round up or round down. When I did nearest hundredth, I looked at the third number to see whether to round up or round down. Same thing with the 1.4. I looked at the hundredth to see whether to round up or round down. So it's understood all of these have been rounded, not just truncated, meaning they just got chopped right off. Okay, so that is the end of converting from degrees to radians, radians to degrees. So one last thing we need to do is to do coterminal angles, which I briefly talked about. So I'm going to save this guy. So again, why don't you go ahead and get out of here, this particular video, and go on to video 3. And I will see you in a little bit.